Hi guys, we are back with a new video about facts about 3D printing. I appreciate your taking the time and watching my video. I am grateful for your support to grow my channel. Please share your opinion about my channel and all videos in the comments section and let me know what type of video you like to see more. Please subscribe my channel and ring the notification bell and share my video with your friend if you like. Thank you for your support. Love you all, Zach Land. 3D printing or additive manufacturing is the process of making three-dimensional solid objects from a digital file. The creation of a 3D printed object is achieved using additive processes. In an additive process, an object is created by laying down successive layers of material until the object is created. Each of these layers can be seen as a thinly sliced cross-section of the object. 3D printing is the opposite of subtractive manufacturing, which is cutting out, hollowing out a piece of metal or plastic with, for instance, a milling machine. 3D printing enables you to produce complex shapes using less material than traditional manufacturing methods. The adoption of 3D printing has reached critical mass as those who have yet to integrate additive manufacturing somewhere in their supply chain are now part of an ever-shrinking minority. Where 3D printing was only suitable for prototyping and one-off manufacturing in the early stages, it is now rapidly transforming into a production technology. A 3D printer is a computer-aided manufacturing (CAM) device that creates three-dimensional objects. Like a traditional printer, a 3D printer receives digital data from a computer as input. However, instead of printing the output on paper, a 3D printer builds a three-dimensional model out of custom material. What can 3D printers make? Designers use 3D printers to quickly create product models and prototypes, but they're increasingly being used to make final products as well. Among the items made with 3D printers are shoe designs, furniture, wax castings for making jewelry, tools, tripods, gift and novelty items, and toys. A 3D printer essentially works by extruding molten plastic through a tiny nozzle that moves around precisely under computer control. It prints one layer, waits for it to dry, and then prints the next layer on top. Most of the current demand for 3D printing is industrial in nature. Acumen Research and Consulting forecast the global 3D printing market to reach $41 billion by 2026. As it evolves, 3D printing technology is destined to transform almost every major industry and change the way we live, work, and play in the future. Examples of 3D printing. 3D printing encompasses many forms of technologies and materials, as 3D printing is being used in almost all industries you could think of. It's important to see it as a cluster of diverse industries with a myriad of different applications. A few examples: consumer products, eyewear, footwear, design, furniture. Industrial products, manufacturing tools, prototypes, functional end-use parts. Dental products, prosthetics. Architectural scale models and maquettes. Reconstructing fossils. Replicating ancient artifacts. Reconstructing evidence in forensic pathology. Movie props. Rapid prototyping and rapid manufacturing. Companies have used 3D printers in their design process to create prototypes since the late 70s. Using 3D printers for these purposes is called rapid prototyping. Why use 3D printers for rapid prototyping? In short, it's fast and relatively cheap. From idea to 3D model to holding a prototype in your hands is a matter of days instead of weeks. Iterations are easier and cheaper to make, and you don't need expensive molds or tools. Besides rapid prototyping, 3D printing is also used for rapid manufacturing. Rapid manufacturing is a new method of manufacturing where businesses use 3D printers for short-run small-batch custom manufacturing. Automotive. Car manufacturers have been utilizing 3D printing for a long time. Automotive companies are printing spare parts, tools, jigs, and fixtures, but also end-use parts. 3D printing has enabled on-demand manufacturing, which has led to lower stock levels and has shortened design and production cycles. Automotive enthusiasts all over the world are using 3D printed parts to restore old cars. One such example is when Australian engineers printed parts to bring a Delagy Type C back to life. In doing so, they had to print parts that were out of production for decades. Aviation. The aviation industry uses 3D printing in many different ways. The following example marks a significant 3D printing manufacturing milestone. GE Aviation has 3D printed 30,000 cobalt chrome fuel nozzles for its LEAP aircraft engines. They achieved that milestone in October of 2018, and considering that they produce 600 per week on 40 3D printers, it's likely much higher than that now. Around 20 individual parts that previously had to be welded together were consolidated into one 3D printed component that weighs 25% less and is 5 times stronger. The LEAP engine is the best-selling engine in the aerospace industry due to its high level of efficiency, and GE saves $3 million per aircraft by 3D printing the fuel nozzles, so the single 3D printed part generates hundreds of millions of dollars of financial benefit. Construction. Is it possible to print a building? Yes, it is. 3D printed houses are already commercially available. Some companies print parts prefab and others do it on-site. Most of the concrete printing stories we look at on this website are focused on large-scale concrete printing systems with fairly large nozzles for a large flow rate. It's great for laying down concrete layers in a fairly quick and repeatable manner. But for truly intricate concrete work that makes full use of the capabilities of 3D printing requires something a little more nimble and with a finer touch. Consumer products. When we first started blogging about 3D printing back in 2011, 3D printing wasn't ready to be used as a production method for large volumes. Nowadays there are numerous examples of end-use 3D printed consumer products. Footwear. Adidas 4D range has a fully 3D printed midsole and is being printed in large volumes. We did an article back then explaining how Adidas was initially releasing just 5,000 pairs of the shoes to the public and had aimed to sell 100,000 pairs of AM-infused designs by 2018. With their latest iterations of the shoe, it seems that they have surpassed that goal or are on their way to surpassing it. The shoes are available all around the world from local Adidas stores and also from various third-party online outlets. Eyewear. The market of 3D printed eyewear is forecasted to reach $3.4 billion by 2028. A rapidly increasing section is that of end-use frames. 3D printing is a particularly suitable production method for eyewear frames because the measurements of an individual are easy to process in the end product. But did you know it's also possible to 3D print lenses? Traditional glass lenses don't start out thin and light. They're cut from a much larger block of material called a blank, about 80% of which goes to waste. When we consider how many people wear glasses and how often they need to get a new pair, 80% of those numbers is a lot of waste. On top of that, labs have to keep huge inventories of blanks to meet the custom vision needs of their clients. Finally, however, 3D printing technology has advanced enough to provide high-quality, custom ophthalmic lenses, doing away with the waste and inventory costs of the past. The Luxexel Vision Engine 3D printer uses a UV curable acrylate monomer to print 2 pairs of lenses per hour that require no polishing or post-processing of any kind. The focal areas can also be completely customized so that a certain area of the lens can provide better clarity at a distance, while a different area of the lens provides better vision up close. Jewelry. There are 2 ways of producing jewelry with a 3D printer. You can either use a direct or indirect production process. Direct refers to the creation of an object straight from the 3D design, while indirect manufacturing means that the object, pattern, that is 3D printed eventually is used to create a mold for investment casting. Healthcare. It's not uncommon these days to see headlines about 3D printed implants. Often, those cases are experimental, which can make it seem like 3D printing is still a fringe technology in the medical and healthcare sectors, but that's not the case anymore. Over the last decade, more than 100,000 hip replacements have been 3D printed by GE Additive. The Delta TT cup designed by Dr. Guido Grapaiolo and Lima Corporate is made of trabecular titanium, which is characterized by a regular, 3-dimensional, hexagonal cell structure that imitates trabecular bone morphology. The trabecular structure increases the biocompatibility of the titanium by encouraging bone growth into the implant. Some of the first Delta TT implants are still running strong over a decade later. Dental. In the dental industry, we see molds for clear aligners being possibly the most 3D printed objects in the world. Currently, the molds are 3D printed with both resin and powder-based 3D printing processes, but also via material jetting. Crowns and dentures are already directly 3D printed, along with surgical guides. Bioprinting. As of the early 2000s, 3D printing technology has been studied by biotech firms and academia for possible use in tissue engineering applications, where organs and body parts are built using inkjet techniques. Layers of living cells are deposited onto a gel medium and slowly built up to form 3-dimensional structures. We refer to this field of research with the term bioprinting. Food. Additive manufacturing invaded the food industry a long time ago. Restaurants like Food Inc. and Mellis use this as a unique selling point to attract customers from across the world. Education. Educators and students have long been using 3D printers in the classroom. 3D printing enables students to materialize their ideas in a fast and affordable way. While additive manufacturing specific degrees are fairly new, universities have long been using 3D printers in other disciplines. There are many educational courses one can take to engage with 3D printing. Universities offer courses on things that are adjacent to 3D printing like CAD and 3D design, which can be applied to 3D printing at a certain stage. In terms of prototyping, many university programs are turning to printers. There are specializations in additive manufacturing one can attain through architecture or industrial design degrees. Printed prototypes are also very common in the arts, animation, and fashion studies as well.